Hello, algebra students. Okay, so we are on our last thing of thingies. Last three questions, final review. Let's do this here. Says, compared to a photon of red light, a photon of blue light has a greater. I think in some ways we should know this, but we don't necessarily have to. We can use our reference sheet, the electromagnetic spectrum here. This says we're compared to a photon of blue light has a greater. So if I'm here with red and I go to blue, what am I doing? Well, this way, frequency is increasing. So the blue light has a greater frequency. So if you're going from here to here, you're increasing frequency. Now on the other end, if you said, what are you doing with the wavelength? Let's say, what is decreasing as you go from red to blue? Well, red to blue in this way is decreasing the wavelength. Increasing frequency going this way, decreasing wavelength. I think I've kind of hopefully hammered that in. As you go this way, you're increasing frequency, decreasing wavelength. As you go this way, you're decreasing frequency and increasing wavelength. Use this. Okay. Now, we're going on to the next problem. It says, a photon with a frequency of 7.5 times 10 to the 14 hertz is emitted, that's a hertz is in frequencies, when an electron in a mercury atom falls to a lower energy level. Identify the color associated with this photon. Now this is another one that where it could be tricky if you're thinking, some people might think you have to use this one. And I guess you could do it that way, looking at it falls to a lower energy level. It doesn't even say which energy level. So I can even do that. But a frequency I know. What color is the light associated with this? 7.5 times 10 to the 14. Well, they say it's a visible light, so I'm looking here. 7.5. Okay, so it is in the violet range. So 7.5 is before 7.69, which is the beginning of ultraviolet. So it's somewhere here in this range, 7.5. So it would be a violet light. It would be violet. Violet. Easy. Last one. Okay, what's funny is the last one relates to the first one. Okay? So it says the slope of a graph of photon energy versus photon frequency, right? The slope of this graph. Well, I know this. E equals H F. These formulas keep coming up. I think I'm going to talk about this in 1 second when we're finished here. So E is my dependent variable. F is my independent. So what represents the slope here? H. Or in this case, A, Planck's constant. Okay? That's all that is to remember. Now, if you did energy versus wavelength, of course it's going to be inverse, and you would notice the slope was H times C. But here's the three things I want you to know. Big keys. Get a copy, or at least somehow have a copy up on your computer when you're doing this of the physics reference table. Of course, we'll include it with the other materials that I'm sending. So get the physics reference table, and the one big thing I want you to concentrate is on the electromagnetic spectrum. Which is on page 2. Okay. The other important information I'll give you the page. It's in the modern physics section. And that's on page 5. But really, what you need to know is these two formulas just. As we just talked about this, energy equals Planck's constant times frequency. And the other important one is energy equals hc over lambda. Okay? And there's one other that I would add on to that, is the energy of the photon, incident photon, equals the work function of the material plus the energy of the emitted photon. That works with the incident situation. Remember, these videos are going to be up when you take the exam. So if you have questions, look them up. All right, guys, have a great day. Be well and do well on the final. I'm rooting for all of you.